We have made it up to the 1922 Nobel Prize in Physics, which went to Niels Bohr. Officially, it went to him for his service in the investigation of the structure of atoms and the radiation emanating from them. Now, that's all great, and that's fantastically phrased for scientists to understand, but what the heck does that mean to the rest of us, and why do we care? Well, let's take a look. All the discoveries in the latter part of the 19th century with the electron and radioactivity and all those other Nobel Prizes we've already discussed, led to different models being proposed for atomic structure. And in 1913, Niels Bohr proposed a theory for the hydrogen atom. And I know what you're saying. You're showing us an atom with 6 electrons, but I like carbon. I'm a carbon-based life form, so we went with that one. But what he was basing his model on was quantum theory, that whole new quantum mechanics thing that was running around the physics community, that some physical quantities can only take discrete values. So electrons can move around the nucleus in certain orbits, and if something gets excited, it goes from an orbit that's close into the nucleus of the atom, it goes to an orbit that's further away. But those things only happen in discrete energy levels. And when that atom is less excited, the energy drops back down, and it drops back down to a spot where it's closer to its ground state, which is the closest state it orbits near the nucleus. And when it does that, it emits light of a fixed wavelength. And then he later incorporated the theories of light quanta. So he won the prize for a lot of work on atomic structure, because before then we didn't really understand it, and we didn't really understand how it worked. So he proposed one that is still studied even today. It works pretty well for hydrogen. It kind of doesn't work as well for some of the other ones, but considering when he did this work, it was groundbreaking at the time, and it is still shockingly important in laboratories even today. Now, there's probably a scientist out there somewhere going, hey, wait a minute, Dr. Imholt, you just said his model doesn't work for all the atoms, and I heard it does. And you'd be right, it does. There are certain things in his model that don't, such as he said all the electrons go in perfect circles, and they don't. Sometimes they go in ovals and other things. But his work on the energy levels was just spot on perfect. So as you go from one energy level to a lesser excited state, you do have that release of energy. You have a release of angular momentum. The electron's not as perturbed as it was, if you will. And it does come off with the amount of energy lost is directly proportional to h times v. So it gives you a specific wavelength of light. You've seen an equation like that in one of the other videos that I had a couple of Nobel Prizes ago. So this does hold with all that fun quantum theory stuff that was running around at the time. And he was the first to really sit down and model it out and go, yes, you guys over in quantum, you're exactly right. Here it is, in the hydrogen atom, and boom, here you go. And next thing you know, we have this model that works in labs all over the world, and we actually understand atomic structure a lot better. I think it's important to note also that at this point in physics and science in general, we're coming out of a time period where we always thought one way. We always had this classical view of things, and now we're going into this quantum world and more advanced, more recent. What we now look at is sort of historic physics, but at the time it really wasn't. This was all brand new stuff, and it wasn't really all that well respected in some cases. It wasn't really all that well believed in some cases, and sometimes you had to have people out there whose job was partially to go off and do the science, but also to kind of bring the community together and actually start to look at these things and take them seriously. And Niels Bohr was one of those guys who would go around and kind of work with people to say, hey, look, here's how you get it accepted by the scientific community at large, because you're disrupting hundreds of years of people believing the same thing. Now, you do have to have proof. You do have to have well-written papers. You do have to have well-researched stuff. You just can't go off and make a claim. But he was one of the people who kind of helped do that. And there really is sort of a softer side to physics where that becomes very important. Softer side of chemistry, just any career field. But he was one of those guys who was known and well respected by everybody, and you might recognize the guy in the background there. Now, Niels Bohr also did work on other things besides just his atomic structure things. Pictured here in 1950 is the Niels Bohr on the left and a gentleman named Oppenheimer on the right. Both of them worked on a specific project out in the New Mexico desert at the tail end of World War II called the Manhattan Project. The Manhattan Project, as many people are aware, was what gave the United States access to nuclear weapons. We were the first country in the world to have them, first and only country in the world to use them. And we used 2 of them, one on Hiroshima and one on Nagasaki. We were a couple of weeks away from having a third one ready to drop when the Japanese surrendered. And these 2 gentlemen played no small part in that project. Now, the debates on whether or not that was necessary are a completely different topic area, but Niels Bohr and his work on atomic structure, that's not where he stopped. He continued his work in the nuclear age and brought us many interesting developments, and was a compatriot of many of the people you've heard of and that have won other Nobel Prizes, including Einstein and Zwicky and all kinds of them. So everybody, I hope you've enjoyed this video. Please don't forget to click subscribe or like, and we'll see you on the next one.